Okay, this is chemistry, our gas law unit continued. Here we're going to focus on how to solve the ideal gas law. So I'm just going to show you two examples that deal with the ideal gas law and how to solve them mathematically and what to do with the units. So again, some of you are quite capable of just following this, plugging it in yourself, and understanding how to do the math on your own. Some of you need a little bit more explanation, so I've gone through this step by step in terms of what to put into the calculator and how to cancel out your units. So I hope this helps. All right, so let's just take a look at our first example. It says a sample of hydrogen gas has a volume of 8.56 liters. So right there, as you start to solve this, start to think about what letters have been given to you and which letter is missing. So right here, this volume, that's V. So we have V at a temperature of 0 degrees Celsius. So temperature is T, and remember, Celsius will need to be converted to Kelvin. And a pressure of 1.5 atm. So that's P. So right there, I've got V, I have T, and I have P. So there's one variable missing. But then if you keep reading, it actually indicates the variable anyway. It says calculate the number of moles of hydrogen present in this gas sample. Assume the gas behaves ideally. So right there, number of moles is the letter N. So here we go. Here is the ideal gas law. So PV equals nRT. And this should be capital. Okay, so we have P, we have V, we have T, and then R will always be known. You just have to look it up. So the missing letter is N. So if you can just plug this in as is and solve, that's fine. If you have your own method of solving this, that works for me, as long as you and I end up at the same spot. But I'm going to run through how I would solve this problem. The first thing I would do is isolate the letter I'm looking for. All right, so what I did is I got N by itself. So to get N by itself, I divided by RT. Okay, so this is PV over RT equals N. And then I just rearranged it to have the N on the left because that's just more comfortable for me. You could have had this PV over RT equals N and switched it to be on the right-hand side. Really makes no difference. And again, you could have just plugged in your numbers and solved. Again, makes no difference. This is just how I was trained. Okay, now let's start plugging in what we know. Okay, from the problem, 1.5 atm is our P. From the problem, 8.56 liter is our volume. So that was in the problem right up here. There's our V, there's our P. Okay, now R. Okay, so R is 0.0821 liter atm over mole K. So why did I choose the 0.0821 of all? You have 4 values for R. Why did I pick this one? R is based on pressure. So my pressure was an atm. So I chose the R that has atm, and that happens to be 0.0821. You do need to include all 4 units. So using this value for R will help you eliminate the units you don't want and help you solve for the unit you're looking for. So it's liter atm over mole K, so all 4. And then what is this 273 Kelvin? That is my temperature, but 273 was not given to you. 0 degrees Celsius was given to you. So you have to add 273 to convert it to Kelvin. So here's how I plugged in my values. Okay. All right. Now, what I've done is started to simplify this. So this 12.84 is 1.5 times 8.56. And now I'm color coding the units so that you understand what units are going to cancel to help you determine the proper unit. Or you might just know that N needs to be in mole, and that's completely fine. But I want you to know how the law actually helps you solve this. So I put ATM up in green. And then L I put in purple. So these didn't go anywhere. I just multiplied my numbers. So 1.5 times 8.56 is 12.84. ATM and L are still there. Now on the bottom, 0.0821 times 273 is 22.41. Now all of my units haven't gone anywhere, right? So my liter, just like liter up here, is purple. ATM is green. I put K in orange. And then this hasn't disappeared, right? For R, you still have that mole K. So mole is blue, and K, again, will be orange. So anything that's matching in color can now be eliminated or canceled. Okay, and if it helps, okay, I can do this as well. Cancel, 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 cancel. So the one that I didn't cancel is what I'm looking for, right? So mole is what N represents. So now to solve, 12.84 divided by 22.41 equals 0.57 mole. And again, I'm not stressing the significant figures. You're welcome to follow them. So in this case, I would need 2 more decimal places if I wanted my 4 significant figures, but really that's not necessary. Okay, so 0.57 mole is the answer. Okay, all right, so let's move on to my second example now. All right, so now we're being asked what volume is occupied. Well, actually right there you have the letter that you're looking for. What volume? So if you're asking what volume, that means that's what you're trying to find. Is occupied by 0.250 mole, which is N, of carbon dioxide gas at 25 degrees Celsius. That's my T. And remember that T needs to be converted to Kelvin. And 371 torr, and torr is pressure. So you have N, T, and P. So the missing variable is V. R, you have to look up. So here we go. PV equals nRT is the ideal gas law. So again, you can set this up and solve it any way that you'd like, as long as you and I come up with the same answer. My training is to isolate the letter that I'm looking for and then solve. So in this case, we're trying to find V. So to figure out V, or to get it by itself, I simply divide by P. So V equals nRT divided by P. So now V is alone, I can put in my values and solve for it. All right, so let's take the numerator, right? So 0.250 mole was in the problem. R I chose as 62.4 liter torr over mole K. Why did I pick torr, or the 62.4? Because up here, my pressure was torr, and the value for R that uses torr is 62.4. 298 K, that is my temperature. I was not given 298, but I was given 25 degrees Celsius. 25 plus 273 K is 298 K. Okay, divided by 371 torr, which was provided in the problem. Okay, 0.250 mole from the problem. 371 torr from the problem. 298 K arrived from adding 273 plus 25 degrees from the problem, and then R I had to look up, and I chose the one that matched torr, or my unit of pressure. All right, now I'm going to color code my units and then show you where these numbers are coming from. So this 4648.8, where did I get that from? 0.250 times 62.4 times 298. These values are next to each other, so you multiply. Okay, now I'm not getting rid of any of my units. So again, I color coded this. Mole, I turned it orange. Liter is what I'm trying to find. Okay, there's no, or I just left it as blue. Torr is green. Kelvin is purple. Okay, so I'm going to match that now to the mole here, also orange. The K here, purple. And then my torr on the bottom, I'm going to use green. Okay, so now you're going to be dividing your numbers. But if it helps, to show what's going to cancel, mole and mole cancel. Torr and torr cancel. Kelvin and Kelvin cancel. So the unit I did not cancel was liter, or you might just have known that volume is solved in liters. So if you divide now, 4648.8 divided by 371 leaves you with 12.5 liters. And again, I'm not stressing significant figures. This time I did happen to match it. I should have 3 significant figures, but that is not necessary when you're solving the gas law problems. My concern is that you understand how to actually set these up and solve.